Hello and welcome to today's lesson about square numbers. First, let's talk about some important vocabulary words and terms that you will need to understand today. Our first term is square array. This is a rectangular array with the same number of rows as columns. For example, 16 dots will form a square array with 4 objects in each row and 4 objects in each column. This is a picture of a square array. Next, we have the term square number. This is any number that is multiplied by itself to come up with a product. For example, 25 is a square number because 5 times 5 is 25. You can see that we multiplied 5 by itself to get the product 25. Another way to write this is 25 equals 5 squared or to the power of 2. Our third term today is exponential notation. This is a way of representing repeated multiplication by the same factor. For example, 2 to the power of 3 is exponential notation for 2 times 2 times 2. The exponent 3 tells us how many times the base 2 is used as a factor. This is the exponent, and this is the base. Our final term for today is exponent. This is a small raised number used in exponential notation to tell how many times the base is used as a factor. For example, in 5 to the power of 3, the base is 5, and the exponent is 3, and 5 to the power of 3 equals 5 times 5 times 5. The exponent 3 tells how many times the base 5 is used as a factor. Now let's talk about finding other square numbers. Let's look at the following numbers: 1, 2, 3, and 4. Can square arrays be drawn for these numbers? The number 1 can be represented by a square array because it has the same number of columns as it does rows, 1 of each. The number 2 cannot be represented with a square array. No matter how you look at it, it has a different number of rows and a different number of columns. This first way, it has 1 row but 2 columns. The second way, it has 2 rows but 1 column. This is not a square number. The number 3 also cannot be represented by a square array. As you can see, in the first way, we have 3 in the row and 1 in each column. This is not a square. In the second way, we have 1 in each row and 3 in the column. This is also not a square, so 3 is not a square number. In looking at the number 4, you can see that it is possible to create a square out of its array. It has the same number in each row, 2, as it has in each column, also 2. 4 is a square number. Here are a couple of examples of square numbers. I have already told you that the first 2 square numbers are 1 because its array looks like this, and 4 because its array looks like this. What number sentence represents each of these square numbers? For the number 1, our number sentence is 1 times 1 equals 1. The number model that represents this array for the number 4 is 2 times 2 equals 4. What pattern do you see? What do you think the third square number is? If you guessed that the third square number is 9 with a square array that is 3 dots by 3 dots, you were right. The number sentence that represents this array is 3 times 3 equals 9. The fourth square number is 16. Its number array is 4 dots long by 4 dots wide, making a 4 by 4 square. The number sentence that represents this array is 4 times 4 equals 16. A square number is simply a number that is multiplied by itself to find a product. Here is your practice problem for the day. Find the 6th and 7th square numbers. Please make sure to represent each of these numbers with a square array and a number sentence that shows how you got your square array.